Well, now let's talk about externalities, another stop on our tour of contexts where markets don't work so well. So what is an externality? Well, a lot of words here, but it's an effect on a non-consenting third party arising from the production or consumption by somebody else. Examples help make clear what this idea really is. So let's think about some demand-side examples. So first one that comes to mind is secondhand smoke. So, who's the first party to this transaction? Well, the person who decides to smoke, buys cigarettes and smokes, but then blows out some smoke, which causes other non-consenting people to endure some negative experience. So that smoke being experienced by those other folks is an externality. How about education? Well, so if I go out and buy some education for myself or for my children, I'm the party to the transaction, but there are other folks who aren't in the transaction who are also going to be affected. My kid may go and cure cancer, or if I don't buy education, my kid go and commit crime. So there are other parties affected by my decision to educate my child. Similarly, my decision to get vaccinated, of course it helps me, but because once I'm vaccinated I don't spread the disease to others, it has an external effect on these other third parties. So those are just examples of externalities. Some of them are positive, some of them are negative. There are some supply side examples of externalities as well, like pollution. So here the idea would be, I make some stuff, my firm makes some stuff that people buy, but in the course of making stuff, I also generate some pollution. So if you think about the total cost of the stuff I make to society, it's not just the private marginal cost. There might be some additional costs associated with the use of, let's say, clean air and clean water and turning them into dirty air and dirty water. Anyways, we'll see some more specific examples as we go, but you can already see that there are many kinds of examples of externalities, these effects on third parties who aren't consenting to the transaction. Now, it turns out that there are two different ways to think about externalities, depending on whether property rights are defined and depending on whether negotiation is possible between, say, the folks producing the externality and those experiencing it. Now, first, let's suppose that's not feasible. So we'll start out with the case where negotiation is not feasible, and then we'll come at the end to the case where it is. Let's start with the example of positive externalities in consumption. And so, so for example, when I get vaccinated or educated, or if I plant flowers in my yard, who benefits from that? Well, certainly I do. So the first person who benefits from that is me. And if that were the whole story, we wouldn't be talking about externalities, but also others. Others also benefit from my decision, and that's the sense in which there's an externality. The question is, do I take those others into account when I choose how much of each of these things to buy? And the answer is maybe not, or maybe not enough. Okay, but if, sort of the strictly selfish economic story would be, we assume that people just care about themselves, so they don't take account of the positive effects on others when choosing how much of these things to buy. As a result, folks are going to underconsume things that have positive externalities for others. What would this look like in a diagram? So this diagram is in many ways familiar. So this is the quantity of some good on this axis. You could think about it as vaccinations or flowers or education, things where there are these positive external benefits. So there's a curve here called MPB. Think about that simply as the traditional private demand curve. MPB means marginal private benefit. So now, because we're making a distinction between the private benefits and the social benefits, we're going to relabel the demand curve and call it the marginal private benefit, but it's what we've been calling demand all along. Marginal social benefit is both the demand as well as the additional effects, the additional benefits on others. So because my flower purchases confer a benefit on me as well as others, the social benefit exceeds the private benefit at any quantity. Now, what does a market do? Well, in a market, as we've seen many times in this course, the equilibrium occurs at the intersection of supply and what we used to call demand, the marginal private benefit, and so that's the actual quantity that gets consumed in the marketplace, and that's the price. But what would have been optimal would be to continue consuming up to the place where the marginal social benefit equals supply, and that would have been this quantity here, Q star. Now, if there's an upward sloping supply curve, as there is here, then the price would have been higher as well. But let's focus on the quantity. In some sense, the big point here is that when there's a positive externality, then the actual quantity consumed falls short of the optimal quantity. And indeed, there's deadweight loss. Now, what's this deadweight loss? Well, when we only consume out to here, then we're missing out on an opportunity where the benefit to society of an additional unit is way up here, but the cost is just down here. We're missing out on this vertical distance. And we can add those vertical distances across all these units, and this region in here is the deadweight loss. It's the deadweight loss from not consuming units with marginal social benefit above, I'll just say cost, because we understand the supply curve reflects marginal costs. All right, summing up, if there's a positive externality, the market by itself leads us to underconsume, and that underconsumption gives rise to a deadweight loss represented by this triangle. Now, what about negative externalities in production? So pollution is the classic example. And how do we think about this? Well, if I'm a producer, when I make stuff, I have direct costs of inputs that are priced in markets, and that's exactly what gave rise to the marginal cost curve, which in turn gave rise to the supply curve. Remember, the marginal cost curve above minimum average variable cost was the supply curve. So those inputs I purchase are things like labor and materials and so forth. And that's, again, the stuff that goes into the marginal cost or marginal private cost. But I also use some inputs that I don't pay for. What am I thinking about here? Well, maybe I use some water or some air. I take in some clean air and belch out some dirty air. Those aren't priced in markets. Nobody owns the air. And so I don't actually pay those costs, but I impose those costs on society. If that's the case, then the costs that go into the traditional supply curve can understate or will understate the full marginal costs of output. If that's true, then I may overproduce. What does that look like in a diagram? Well, here we go. So now demand is as it always has been. So you could have called that marginal private benefit, but there's just a regular old demand curve. We've got a regular old supply curve here too, but now we'll distinguish between the private costs and the social costs. So MPC is the marginal private cost, and again, it's just the traditional supply curve. Marginal social cost shows that the vertical difference here is the additional cost per unit of output associated with these unpriced inputs. So imagine we were attaching a cost to dirtying the air or dirtying the water. We'd say, well, the marginal social cost, including all that stuff that's not being paid for directly, is represented by this MSC, or marginal social cost curve. So what happens here? Well, the actual demand and supply curves that happen in markets give rise to this intersection and this actual quantity of this output being produced. If the firms had faced the full costs of producing stuff, that is, if they had to pay for the air and the water, then marginal cost would have intersected demand here. Quantity would have been lower, and in this case, the price would have been higher. So summing up, producers use some inputs without paying, clean air, clean water. This happens because property rights to the air and water aren't assigned. If they were assigned, if somebody owned them and could charge for them and so forth, then the firm would actually pay for the air and water it dirtied, and it would face private costs of using the air and the water. But since that stuff's not owned and not priced, this ends up just being an externality, and the market gets the answer wrong. Well, now, without regulation, then, continuing, externalities can generate market failure. For example, left alone, people might vaccinate or educate or plant flowers too little, and they would tend to pollute too much. And so, what's interesting, and it's not the first time we've seen this, but externalities provide a context where government intervention can improve efficiency, in particular, taxation. Taxation can improve inefficiency in the case of a negative externality in production. In the case of a positive externality in consumption, you very well might want to impose a negative tax or a subsidy on the good. So we've got this theory of externalities. How would we actually work a problem in this area? Well, here's an example involving flowers. And flowers are an example of a good that produces a positive externality, so that the private benefit, the private demand for the product understates the social benefit of the product. Anyways, suppose that the private demand for this product, flowers, is equal to P equals to 100 minus Q. And let's suppose that supply is given by P equals 20 plus Q. So the market equilibrium with that problem, which is a familiar problem to us, is just that the price equals 60 and the quantity equals 40. And remember how you do that. You just set those two P's equal to each other. If you solve 100 minus Q equals 20 plus Q, you get that 80 equals 2Q, or Q equals 40. Taking it back to the demand or the supply curve, you get P equals 60. Anyway, so far, no externality. But now let's suppose that flowers produce a positive externality of 10 per unit. So that means we need a different marginal social benefit curve, which here we would say now is P equals 110 minus Q. So it's just like what we had before, except we've added $10 in benefit at each quantity. So now we've got P equals 110 minus Q. If the question were find the optimal quantity, what we would do is we would set 110 minus Q equal to 20 plus Q. What are we doing there? We're just setting the prices on the marginal social benefit curve equal to the price on the supply curve. If we solve that, we end up with 110 minus 20, or 90, equals Q plus Q, or 2Q, so Q equals 45. You know, before we get lost in the trees here, remember the market equilibrium was 40, but the optimal quantity is 45, and that's entirely consistent with what we would expect. This good has a positive externality, so market participants left to themselves consume too little of it. All right, we could go a little farther, and we could ask the question, how would we literally achieve this? So what policy instrument could we use to cause this to happen? And the answer is, well, it's like a tax, but it's kind of a negative tax or a subsidy. So we're going to achieve this with a subsidy of 10 per unit. But let's work through the math of that. So what that means is that sellers receive more than the buyers pay. So the price on the supply curve exceeds the price on the demand curve by 10. So we could write that out as follows. Here's the price on the supply curve, P equals 20 plus Q, and then minus in parentheses the price on the demand curve. Now this is just the regular old demand curve, 100 minus Q, and that equals the amount of this subsidy, 10. If we solve that through, so in the next line we can rewrite all this as 20 plus Q equals just adding 100 to both sides and subtracting Q from both sides. We end up with 20 plus Q equals 110 minus Q. And the solution, this is exactly the problem we posed in the last page. The answer is Q equals 45. So this is just a way of saying that a subsidy of 10 per unit would achieve the optimal quantity. Now, we can also go a little further and make a distinction between what the buyer pays and what the seller receives. And we have that here with a subsidy, just as we had that with a tax, although here it's a little different. So the buyer pays, and we put the quantity into the regular old demand curve, P equals 100 minus 45, and the buyer pays 55. What does the seller receive, though? Well, the seller receives this quantity 45 plugged into the supply curve, so 20 plus 45 is 65. Now, of course, that makes sense because the seller is receiving 10 more per unit than the buyer is paying, the difference being the subsidy. 45 units are being transacted, so the cost of this subsidy to the payer, who's presumably the government, is 45 times 10, or 450. Now let's move to the second part. Remember I said at the outset that there are two different situations. One is the situation in which negotiation is not possible between the entity producing the externality and the entity experiencing it. Suppose now instead that it is possible to negotiate between the guy producing the yuck and the other guy who's experiencing it, and I'll show you what I mean. So here's this example, hypothetical example of a factory and some fishing enterprise that's literally downstream from the factory. So the factory produces some negative externality. It pollutes the water, which reduces the fish harvest. Let's suppose there are two possible technologies for cleaning up. So the factory can install a filter, or the fishing firm downstream can do water treatment. So there's a filter that the factory can do, or there's treatment that the fishing firm can do. And, you know, the question is, well, who should clean up this mess? And I think one's first impulse is to think in kind of elementary school terms, well, whoever made the mess should clean it up. I think that's our first impulse. But that's not necessarily the right answer. So let's consider the profits or payoffs associated with various different actions. And so here in this first column, or this second column, I guess, is the profit to the factory. Here's the profit to the fishing enterprise. Now here are the actions over here. So first of all, neither entity could clean up. No filter, no treatment, in which case the factory would earn profits of 500 and the fishing enterprise would earn profits of 100. If there were a filter but no treatment, so that means the factory cleans up. So let's just be clear, that means factory cleans up. We would have factory profits of 300 and fisherman profits of 500. So in other words, it costs the factory 200 to clean up, and this restores fishing profits to 500. On the other hand, we could have no filter but treatment. So this is the case over here where the fishing folks clean up using their treatment technology. In that case, factory profits go back up to where they were if the factory didn't have to do anything, back up to 500. And the fishing enterprise profit is 200, so it costs them 300 to clean up. Now we could also think about filter and treatment. It's kind of a silly option since either one cleaning up cleans up, so let's just ignore that. So those are the various possibilities. Now let's suppose the factory has the right to pollute. Well, what is it that happens by default? Well, meaning what is it that just simply happens given that the factory exercises its right to pollute? Well, what happens is that we get no filter and treatment. So the factory goes ahead and pollutes and the fishermen go ahead and clean up. So the fishermen get 200, factory gets 500. That's what does happen. Let's contrast that with what we would like to see happen. Now, what is it that we would like to see happen? Now, I suppose there are a couple of ways to think about this, but let's think about it from the standpoint of economics. What would be the best thing to see happen? And really the best thing is whatever minimizes the cost of cleaning up or maximizes the total profit. And if we look at this last column with total profit, this is the best outcome, 800. So what we would like to see happen is this row here. The question is, though, will that happen if the factory has the right to pollute? So remember, if the factory has the right to pollute, they go ahead and pollute. By default, we're here. So let's think about this. What if the factory and the fishermen negotiate? You know, we could ask the question, what does it cost each party to clean up? Well, basically, it costs the fishermen 300. It only costs the factory 200. How do I know that? Well, the factory profit falls from 500 to 300 when the factory cleans up. So it only costs them 200 to clean up. What does it cost the fishermen? Well, fisherman profit falls from 500 to 200 when the fishermen clean up. So it costs them 300. What if they could negotiate? I mean, what's pretty clear is that the fisherman's willing to pay up to 300 to do this, and the factory only requires 200 to do this. So what if the fisherman were to transfer compensation of let's say, more than 200 to the factory? Well then, since it only costs the factory 200 to do it, the factory is at least as well off. If it's more than 200 that gets transferred, the factory becomes better off. How about the fishermen? Well, suppose they transfer $205, then their profit goes from 500 down to 295. The factory profit, goes from 500 to, or from rather 500 to 300, but then they get compensated back 205, so it's 505, and we get back to this box here. So if they can negotiate, the party that's the least cost cleaner-upper can get paid by the higher cost cleaner-upper, and we get the efficient outcome. Now this is such an important discovery, this idea that negotiation can lead us to the efficient outcome. It has a name, named for Ronald Coase, famous economist, and the idea of the so-called Coase theorem is the following. Regardless of the initial assignment of rights, if parties can arrive at the efficient solution if they can negotiate. So even though the default assignment of rights put us here, they could negotiate and they would find themselves here, because this party, the fisherman's, willing to pay more than 200 to do something that only costs the factory 200 to do, and so we do end up with 800 in total profit. Now, before we get too giddy about the Coase theorem and its wonderful nature, because think about what the Coase theorem sort of means to say. It means to say, hey, externalities aren't really a problem. We don't need government intervention. People could just negotiate. But there's a big if there. If there are transaction costs or impediments to bargaining, so if folks can't sit down and talk to each other to work out these negotiations, then private actors cannot achieve socially efficient results. Now, it worked fine when there was one polluter and one victim, because they could sit down. But a lot of situations have, let's say one polluter and lots of victims, or lots of polluters and lots of victims. I mean, here's a single smokestack. Here's a few of the billions of people trying to breathe in China. It's very hard for all of these folks to sit down and negotiate. And so it's not going to be easy for them to negotiate their way to the efficient solution. And in situations like that, where it's difficult to negotiate, then the initial assignment of rights matters. So here it would matter a lot whether you had a rule that said the factory that pollutes has to install scrubbers to prevent this stuff from going up the smokestack, versus a rule that says no, they don't have to, so therefore these guys have to wear masks and and gasp and potentially die early. It's not clear which one's more efficient, but whichever one is the one that you have to apply as the rule, since they won't be able to negotiate. All right, what are our takeaways on externalities? Well, first of all, what are externalities? And the idea is that demand, the regular old private demand we've been working with all semester, may misstate the social benefit, and the regular old supply may misstate social cost. If so, then the market will deliver the wrong quantity, and in that case, taxes or subsidies could actually reduce deadweight loss. So that's kind of novel and interesting. If the parties can bargain with each other, parties causing and receiving externalities, then they can arrive at an efficient solution to the externalities problem, in principle. But if bargaining is not feasible, then the initial assignment of rights through the rules and through government will matter, because it will determine which solution we end up at.